and shut your math boxes for now. And you need out your math notebook and a pencil. Math notebook and a pencil. Alright, so if any of you notice this question up here for you, alright, I want to take a poll as to how many cubic inches you believe would fit in this trash can. Alright, you can't come up and touch it or anything, just I said yes. So when I call your name, give me your guess. Alright, and then we'll kind of visit this later to see if you were correct. So Brooklyn, how many cubic inches, we're going inches, do you think would fit?
Let's say around like
1,000. Molly?
I'm gonna go around 500.
500. Jenna?
1,500.
1,500. Parker, do you want to guess?
I'll go 501.
501. Jake?
640.
640. Kiera?
500.
500. Macy?
641.
Ryan?
900.
900. Evelyn? Yes. Xavier?
Come back.
Calvin?
777.
Very specific. Cece?
800.
800. Sawyer?
720.
Maddie?
650.
Julia?
Come back.
Seth?
831.
Kayla?
1,719.
All right. Last chance to guess. Evelyn? Oh, you're making calculations.
432.
What was it?
432.
432. Xavier?
710.
Julia?
500.
All right. Was that everybody? Looks like it. All right. Like I said, we'll revisit this later. Okay. So, today's I can statements. Yes?
Where are the sheets that I need to do?
In the folders. Okay. Today's I can statements. I can use formulas to calculate the volumes of rectangular prisms, and also I can define the base and height of rectangular prisms. So later, after our lesson, you'll be able to self-assess yourself on these I can statements. All right. So, you should have out your notebook to a clean page. And let me erase this real quick. All right, so we're going to take notes on just a few definitions. Now, using prior knowledge that you already have and these pictures, I want you just take about 30 seconds to talk with someone around you about a definition of a rectangular prism. Okay, use your prior knowledge, use these pictures, get a good definition of a rectangular prism. Yeah, and write it down. That's good enough. All right, raise your hand. What can I write as a good definition of a rectangular prism? Cece?
3D shape.
3D, excellent. Okay, I ask if you don't have this already written to write any new information. What else? Julia, what can I add to that?
A 6-sided 3D parallelogram.
Good, I'm glad you said that. It is 6-sided in a 3D shape. What do we call those sides? They're not sides. Calvin? Brooklyn?
Edges.
Not edges.
Faces.
Faces.
Oh, faces.
Okay, it has 6 faces. Okay. Anything else? Kayla?
It's longer than a square.
Okay. Rectangular prism could be a rectangular square though. So, watch. Yes.
Like you can see through it?
Well, you can see through this one. Can you see through the trash can?
Yes. It has 3 parallel pairs.
Okay, good. It's a parallelogram. All right. Xavier?
It's a rectangle.
Okay, good. It's a 3D rectangle. All right, good. I think this is a good foundation for a rectangular prism. And again, I ask if you don't have these things to write them, jot them in your notebook. And we'll move to the next one. Okay? All right, the next one we're going to do the same thing. Take about 30 seconds, talk with a neighbor, and then we'll come together to make our class definition. All right. Oh, I got to erase this one too. Okay, the next one, base versus height. So I want you to define base and height. Okay, yesterday we talked about base and height of a triangle, but now we're talking rectangular prism. So again, about 30 seconds-ish with the partner.
Base is like the bottom. Height. Base is on the bottom. Height is yeah. Height is how tall and the base is like how wide. Height is how tall it is. Height equals like how tall.
Well, thank you.
Base.
All right. What are we thinking? Let's start with base. What's a good definition of base? Jenna?
Bottom.
Okay, the bottom. Now when we're talking about a 3D prism, what did we say each of those sides were called?
Faces.
Faces. So how can I use that in my definition?
The bottom face.
The bottom face. Good. The bottom face. Okay, generally the one like touching the floor. All right. What else can I add for base, Kayla?
That is the bottom.
We have that.
It's the height on the side.
We don't want to mix the two. Okay. The bottom. Yes, you're right. Molly.
Base times width.
Okay, we're going to go length times width. Length times width. All right, which we've talked about with our rectangles. Yes.
It's horizontal.
Good. It's horizontal. All right, now let's talk about the height. Okay, use these pictures. Okay, I'm looking for kind of specific words here. How am I going to use my base to define my height? Sawyer.
The height is adjacent to it.
Okay, good. You're on the exact track I want you to. Okay, so before you brought up that they were parallel, correct? Okay, so the height connects what?
The base and the top.
Good. The base and it's parallel face. It's parallel top. Good. So the height, it's vertical, and it connects base to adjacent side. I really like that word, adjacent. So it connects the base to its parallel face, its parallel side. All right. So if we look at this rectangular prism, all right, we have our base here and our height. Well, this face and this face on the top and the bottom, okay, they're parallel. They'll never touch. But the height connects those two. Okay, so that's how a good definition of that. All right, any questions when it comes to base and height? All right, our last set. All right, we have area versus volume. Okay, again, talk with your neighbor and get a good definition for area and volume.
Area is area. Well, the area is the volume. No, like how many square you the area is how much fits into a two-dimensional shape. And the area.
Do you have any questions? We need to go over inequality something before you. All right, so let's narrow down area. So how can we define area? We've talked a lot about area in the last couple days. Jenna?
The measurement instead of like the middle of a figure.
Okay, so the middle of a figure. How can we get a little bit more specific? But I like the start. Yes.
Base times height.
Base times height. Okay, base times height. more triangles. What about a rectangle? What do we use with that one?
What do you mean?
What terms do we use with that one? Length times width. Good. Okay, so we have length times width. That's going to be our formula that we've been talking about. How else can we define area? Molly?
It's like how to find the inside of a 2D shape.
Good. That's probably the most important thing. Okay? Inside 2D shape. Alright? So 2D is kind of key there. We only measure area in a 2D shape. Yes, Xavier?
Oh, I'm doing football.
Oh, well, good. Alright, Xavier, volume.
Length times width times height.
Good. So here we add in the height factor, all right, to our area. That's what differs. Okay? And let's see here. Ryan, area was for a 2D shape. What's volume going to be for?
3D shape.
Good. 3D. Good. 3D. So you can look at our fish tank there. All right? And it's still going to be the measure of what's inside, but now it's 3D, so it has height. Okay, so we have the bottom and also height. All right. So now coming around, I'm going to give you this. Don't worry about cutting it, but we are going to put this in our notebook on that next clean page where you can fit it. So when I give it to you, go ahead and flip it over, and then we're going to talk about it together. Jake, I see your hand, and I will get you in just a second.
Do we glue it?
Yes, you can glue it while you're waiting. You're welcome.
Do you think it will fit on this?
If you rip off the black. There you go. You're welcome. All right. How about you take about, I don't know, less than a minute to glue that in. Don't take too long. We'll need to talk about it. All right. Oh, Calvin, don't worry about cutting it. We can cut it later. We won't have time right now. If you will just glue it in. Yes.
Might be super.
Well, I think you should be able to. Yeah. You should be good. That might be his last use. So.
Do you need it?
Definitely.
I think I have one.
Here, I'll put it away. All right. Once you get that glued in, we're going to want to put the formula for area, or I'm not area, my bad, volume right in the middle. Okay, so I wrote formula in there. Okay, it's on the board. We just talked about it. All right, so you're going to want to put the formula for volume right in the middle. All right. You'll just have to do it later, just right now. All right, so in the middle you should have your formula, length times width times height, okay? Or for volume, we could say base times height. And why is that? Look at both of those. Why are they the same thing? Molly?
Because the base is the length times the width.
Good. So here we have base is the length times width, and then we multiply it by the height. Okay, either works. You can write both. You can just write your favorite. Doesn't matter. All right, so on here are two different types of volume problems that you'll come across. Okay, there's a third one that you'll see a little later on. Okay, let's go through this top one. Okay, as you can see, all right, we have a rectangular prism with the height of 12 feet. Okay, then we have a length of 4 feet and a width of 3 feet. All right, and I'm not very good at these, but